Hi there once again, and welcome to another Expresso mechanic tutorial. And in this one we're going to be creating a binary full adder. These are found in computers. They're the way that the computer actually handles addition. And we're actually going to be using this to simulate the addition capabilities of an 8-bit computer. So we're not going into 64-bit, that's a bit over the top and a bit ridiculous. We'll keep it to 8 bits and make our lives a little bit easier by doing so. And the way we'll achieve this is to use logic gates. We'll be using a combination of OR and exclusive OR logic gates within the Boole node. That's what we're going to be about in this tutorial. So without further ado, let's see if we can make this happen. We'll start by bringing in a text spline, and in our text we'll just change the character to 1. Our font, I'm going to select Lemon Milk Pro. If you don't have that, not a problem. You can use whatever font you choose. We'll set its alignment to middle and its height to 20. Just change the camera angle and hit O for object, and we'll get nice and close. And then we can hold down the Option key and drop this into an extrude, and the offset should be 0. I just want 2D objects for this, really. Okay, great. So we've got that far. Let's just rename this. We'll call it 1. Why not? And in our coordinates, set the height to 21. We can then command drag to copy this and call this 1.s for sum. And we can set its position Y to 0. In the text spline, we can change the font to Subway Ticker. And again, if you don't have this particular font, use whatever font you choose to use. Fantastic. Now, what we need to do, we need 8 values between 1 and 128. So 1, 2, 4, 8, 16, 32, 64, and finally 128. So it's a rinse and repeat. Now, these top numbers are just indicators. They're just to give us an idea of what the value is. Well, not an idea, they're just to tell us what the value is. These down here, they will either be 1 or 0 because these are the binary digits. So, as I say, it's just a rinse and repeat. So what I'll do, I'll set all of this up and then come back to you by the power of editing. And I'll just drop these into there. So you can see that what I've done, I've actually reordered them, and I've dropped our sum text into a null named sum, and our decimal indicators, which we've got at the top here, are all in a null so that they're grouped as well. Okay, we're ready to move on from here, and we can think about the Expresso, and that will be our next step. Actually, before we do start with the Expresso, I think I will bring in one more text spline and drop this once again into an extrude. So Option and drop that into there. And what I'll do here, set my offset to 0 once again. With my text spline, I'll just move this down. Move it over here. It's huge at the moment, so we need to do a little bit of work. Let's go into our UI font for a start. I'm going to change that once again to Lemon Milk Pro. Just find that. There we go, Lemon Milk Pro. And on this occasion, I'll make the height 10. Once again, the alignment will be middle. And this is just going to be the text for Overflow. So I'm going to just type Overflow in caps in there. Fantastic. So that's ready when we need it. So we can just call this Overflow. Great. And we can just drop that down the bottom of the list. Fantastic. So we've got all of that ready to go. And now we can think about Expresso. So let's just bring in a null. We'll call it Expresso. And we'll move on from here. Now, in order to get this really working, we've got to be able to add 128, 64, etc. to copies of itself. That's what we're going to do in order to make this work. So in that being the case, what we need is some user data. So we'll add user data and we can work things out from here. I'll add a group and I will name this numbers and then drop my data in there, and this will be 1 to 8 and it will be Boolean is what we want, the data type. That's what that needs to be. Hang on, let's have a look here, see what we've got. Let's just get rid of that. Let's add some new data, drop that into there. Boolean, that's what I want. And that can be 1 to 8. And then it's, again, a rinse and repeat. Copy that, make it 64. 32. 16, 8, and once again I'm going to continue doing this and then come back to you by the power of editing. Just 2 and 1 to go for these last couple. And we've done it. So I've got 2 sets of bools and a separator here. And now with the separator, I've just typed the name, added 2 and a colon after it. There's no separator line, okay? And that's just to distinguish between these two, so that we know that these top numbers are going to be added to the bottom numbers. We hit OK, and we've got our user data in. Fabulous. So that all looks good, and we know that we can use these now to actually power this thing. In the Expresso, we can add the tag. So, programming tags Expresso. We've got our window open and we're ready to start thinking about creating this thing. The first thing to do is actually drag in the Expresso null, and where we've got our user data at the bottom, we've got numbers. We want all of these, absolutely all of them. So we'll bring in those in sequence. And once again, as it's just a rinse and repeat, I'll get it done and I'll come back to you very shortly. And just the last two 128s to finish this off. Okay, fantastic. We've got it all there. And that's all ready to go for us. Moving on from here, we can think about bringing in our first bool. Let's bring that in. Just place it up here. Now, the function we'll set to exclusive OR for this particular one. And then we'll command drag to copy, and this will be a simple AND. Now, so that we don't get confused, in the basic here, I'm just going to name these up. So we can say XOR dash sum, and this one can be AND carry. So this is the sum and this is the carry, because we know that if we're using base 10 numbers, if we add two numbers together and they add up to more than 10, we have to carry. We're using binary here. So if we add 1 to 0, that's fine for the sum. But if we add 1 to 1, we get 2. Can't have that. We can only have 0 or 1. So if we added these two together, the inputs for the AND would both be 1. So the carry bit would be activated in this particular instance. And this, being an exclusive OR, would output a 0, and you'll see that in a second. If we just connect this up, so if we connect 1 to here, we connect 1 to here, and then 1 to here, and 1 to here, we can start to analyze what's going on with these two. Let's just get some result nodes. So we've got 1 there, command drag to copy, plumb these in, and we'll see what we're getting. Now at the moment, nothing is happening. If we select our Expresso, we can see that we've got nothing checked. So technically, we're adding 0 to 0, so we're not going to get anything. If we select 1 here, we can see that the exclusive OR is giving us a value of 1. That's fine, because we're technically adding 1 to 0, because this isn't checked. But if we check this, we can see that they swap, because now the exclusive OR is saying, well, if they're both equal to 1, that's no good to me because I'm an exclusive OR, so I've got to output a 0. My output is going to be false. But the 1 and 1 here, because this is an AND, so if one and the other are both the same, then we get a 1 here. So if they're both 1s, basically, if they're both 0s, it doesn't count. But if they're both 1s, it does. So you can see how that's working. Similarly, if we just had this selected, we'll get a 1 here. So if either or rather if either are 1, that's fine. If they're both 1, we've got to use the carry. Now this is what's known as a half adder. Okay, at this current time, this is a half adder. This is the logic for that. But we want to turn this into a full adder. So we've got to do a bit more work in order to make that happen. What we need to do, we'll just disconnect these two for a minute. We'll keep them though, because we'll use them again. For a start, we need to copy these, so I'll command drag to copy, place them here. Now, let's see where we are. The first thing that we can do is connect the output of this exclusive OR to the input 2 of the second exclusive OR. Now, this input here, I'm going to leave it blank, and you'll see why a little bit later in the tutorial. We will, because we're going to be making 8 copies of what we're going to be doing here, we will be using it in the 7 remaining copies, but don't worry about it for now. We can also connect the output of this exclusive OR to the input 1 of this second carry, so the second AND. Once again, we don't need to connect anything to the second input here, the input number 2 of this AND, because it's just simply not required in this particular instance. But we will need to use it in our subsequent full adders. Now, to finish off the logic for this full adder, we need another boole, so we'll bring one of those in, and this needs to be set to OR in the function. In the basic tab, I'm just going to put OR in there. The output from the carry can be plumbed into input number 1, and the output from our carry here can be plumbed into input 2. That's the logic for that. Okay, so that's working now as a full adder. If we just connect this up here, connect this up here, we can see how this is going to work. At the moment, everything is fine with our sum. There's no problem here because we've only got a single 1 checked. So we're adding 1 to 0 or 0 to 1 if we want to be pedantic about it. If we check both of them on, we now get the same result as we got before, because we know that we can't add these two here, because 1 and 1 is 2, so that makes a false output here. Again, we've got 2 zeros here because this is 0, this is 0, so we get a false output and we get 0 here. we get an AND here, so we're getting a positive output. The fact that we're getting a false output here basically is fine, because we're sending a 0 to here. This is going to be a 0 because neither of these are 1 and we need them both to be 1. So that's a 0 here. Goes into this input, but we do get a positive output here. And this is an OR, so one or the other or both is fine. And that gives us a positive output here and allows us to use the carry. So that's the logic for a full adder. And we can move on from here and take our next step. This is where things get interesting. I'll just move this result node over here. And what we need to do is select all of these, and then with the control key held down on my Mac, I'm going to say convert to X group, which is something we've not done really in a tutorial before. But now we've got all of our nodes collected together in one group. And I'll rename this X group 1 because it deals with our 1 bit over here. As we can see, we've got our result nodes plumbed in accordingly. And we just need to rearrange those slightly so we can leave those there. The next thing that we need to do is actually create a copy of this. So we'll command drag to copy, make our window a little bit bigger, and then we can position this beneath our first full adder. And we can call this one 2. At the moment, we've got the same number of inputs as our number 1 adder. But we actually need to add another one because we need to deal with the carry bit. So what we need to do is in here say that we want another integer. And we've got it down here. If we wish to, we can rename the port and simply call it carry. No real need to, but we can if we wish to. And then we can think about plumbing in our inputs here. Well, this is going to be dealing with our 2-bit, so we'll plumb our top 2 into the first and third inputs and our bottom 2 into the second and fourth inputs. And then we'll move this carry to the top, so hold down Option, get a hold of it, and we'll move it up to the top. And that's ready to receive what's coming out of this OR. Now, these are actually back to front. So what I'm going to do is hold down the Option key here and just move this one up there. Now they're correct. That's how I want to see them. So we've got the sum at the top and the carry at the bottom. And then we can take this from here and plumb it in here. We can then copy these and plumb them in accordingly. Now at the moment we can see that we've got nothing coming out of either of them, and if we select our Expresso null, it's pretty obvious what's going on. Now let's have a look, see where we are. Our carry bit has been brought in here, and that needs to connect to our sum. So we'll connect this in here, and straight away we can see that we've got a difference. We also need to connect it to our input 2 of our carry here, and that completes the setup. It was already working, but that's fine because the exclusive OR would have trapped what was coming in here, because that would have sorted that out. So that's all working perfectly well. So our carry would have been taken into here and worked out from there. Now at the moment, these are actually back to front. So again, let's just move them. Let's just get a hold of our Option and drag this up to the top. So we can see now that this makes actually more sense. Let's just take that down there, put that up there. This makes more sense because we've taken what's coming out of this carry and it's gone into the sum and come out of here, and that's fine. So our 2 bit is now working because 1 and 1 are 2. Let's make this a little bit more clear by adding the next part of this in. What we need is a condition node. So we'll bring in a condition. In fact, we need 2, so we'll bring both of those in by command drag into copy. And when this comes out of here, we can plumb this into the switch, and we'll do that with both of them. Plumb that into there. And then we can decide what we're going to do with these. We'll select both of them, and in our parameters, we simply need to put a 1 in input 3. And then we can bring in, from our sum extrudes here, we can bring in our text spline for our 1. And in our object properties, select text spline. And we can do the same with our 2. So we'll bring that in, place it here, text spline. And let's see what's going on. Well, we can see that our 1 is now 0 and our 2 is 1, and that's exactly what should be happening because we know that 1 and 1 are 2. So this should be the bit that has a 1. Absolutely correct. Now let's just select Expresso once again and take this away, and they change. So there's 1 here because it's 0 plus 1 is 1, and of course our 2 becomes irrelevant, and we can see that here. We've got a 1 at the sum, perfectly good, and nothing anywhere else, and that's exactly what we should have. So you can see how this is working. From here on in, it's another rinse and repeat. I've got to create another 6 of these and set them up exactly the same as we've got here. So once again, I'll start doing it, and then by the power of editing, I'll come back to you when it's all sorted. Just bring in the carry bit from there, and we've got a couple of things to do before we're completely finished. Just bring this into here. And now I think we just need to do a little bit of renaming. So see where we are. Yep. Okay, so we need to rename this one 16, this one 32, and 64 and 128. And finally the 128 there. Great. Everything is now done. Let's just make this window a little bigger, hit H so that we can see everything in it, and we can see that this is quite a large expression. Place this around here just to keep it tidy, but we can see that everything is there. Now let's just see what happens when we start playing around in here. So we know that if we add 1 and 1 we get 2. If we bring a 2 in, we're adding 3 to 1 to give us 4. If we take one of the 1s out, we'll get 3 because we get the 2 and the 1. 2 and 1 are 3. And finally we can start doing some bigger numbers. If we go to 128, we can see that we're adding 128, 2 and 1 for 131. All in binary, of course. We could convert this to digital, but there's no real need to. There's one important point though. If we just take these 2 out and take this out, we've got 128. If we add 128 to 128, we get a 0. And the reason for that is because we've overflowed. That's what we've done. So this is the point at which we need to worry about what we've got down here with our overflow. Now let's just zoom in on here just to make things a little bigger. This final output here, this will be the overflow. So if we were to bring our text from our overflow into here, we can do that, and we can also bring the object properties. We can just use this, we can make it visible. We can make it visible in the viewport. That's the thing that we can do there, or we can simply use another condition. What we can actually do is place this here, connect this, and in this condition we'll change the data type and we'll change it to string, because that will help us do what we need to do. So we'll select the string data type, and in our parameters in the input 3 we'll type overflow in caps, and then all we need to do is pass the output to our text spline, and we've got that there, and we've got overflow there. It was already there, so what we'll do to actually show that it works is go back into our Expresso, take this away, and now it disappears. So we can now say 64 in here, and if we add that to 128 we get the overflow. It leaves the 64 bit there, it can deal with that, but the 128 has to go. Okay, so this is all working, and we can see that it's calculating correctly. If we select, let's do something a little bit more interesting. If we select 32, 8 and 2, and then we select 64, 16, 4 and 1, we can see that we can light all of the bits, and that represents the number 255, which is the maximum number that an 8-bit computer can actually deal with in one pass through the processor. They can certainly add bigger numbers together, but they have to break it down into separate parts and then add things back together afterwards. And that's beyond the scope of the tutorial. There'd be other logic involved in that to do it, but clearly they can do it. I mean, if you think about an early video game, say Space Invaders, that was capable of displaying scores that were much bigger than 255. In fact, all 8-bit games are. So clearly they can deal with those bigger numbers, but as I say, you need a different kind of logic for dealing with that. And you've got to be able to break the maths up into different sections and then basically add the numbers back together. That's essentially what you've got to do in order to make that work with an 8-bit computer. But yes, this all works absolutely fine, and we can see that the carry bits are doing their job absolutely perfectly. So we've got our sums, they're all working, and that's fine. It's all doing exactly what it should do, just by using this very, very simple but clever logic in order to make things add together correctly. And you can see with our first node here, nothing coming in here and nothing coming in here, because of course nothing can be carried. This is the 1 bit, so nothing is going to be carried into here, but all of the others do require the carry bit to pass things down the line. Yes, so there you go. That's how you use logic gates to create a full adder and demonstrate the way a computer adds numbers together. And it's really quite simple but clever. You know, it's quite an elegant system in a way. I mean, in reality, computers actually, they have a way of working out the carry bits. You know, they can actually work out in advance whether the carry bits will actually be used, and that's a more efficient way of doing things. But again, it's beyond the scope of the tutorial really. This is basically the fundamentals of how this stuff works. We're not going really deep into it, but if you wish to go deeper, do a little bit of research on the internet. You may be able to find some diagrams for the logic that can make all of the other stuff happen, and you may be able to incorporate them into this. You know, perhaps there's a challenge there for you. Give that a go, see if you can make it work. But anyway, that just about brings us to the end of this tutorial, because I've shown you everything I wanted to in this one. And as always, I really hope that this has inspired you and given you a few ideas for things that you may be able to incorporate in your own projects. And if you have enjoyed the video, please give it a like. And if you haven't already, please subscribe to the channel, leave a comment, and of course, ring the bell. And wherever you happen to be on social media, please do share this video, because I really need the views, and all this good stuff really does help keep the channel moving in the right direction. But anyway, that just about brings the curtain down on this one. So I'll see you very soon on the next tutorial.